All right, so in this video, we're going to start talking about sales taxes, deductions, and then percents, because percents go along with everything that we're doing in this video. So to start us off, a sales tax is when money is added to the original price. So it's our original price plus the tax itself. A deduction is when money is taken away from the original price. So the original price minus the sale. The equation we're going to be using is the original price times 1 plus or minus the percent as a decimal. So to turn a percent to a decimal, you move it 2 spots to the left, 1, 2. So 94% would be 0.94, or 100% would be 1. Okay, so let's do an example. So we have a video game that costs $50, and there's a sales tax of 8%. So with this, when you have a sales tax or a tax in general, you have to pay the whole original cost plus the sales tax. So how I like to write this is a video game costs $50. So if I paid the whole amount, I paid 100% of its value. But since it's a sales tax, I also need to pay the additional 8%. So I need to pay 100% of the original value plus the 8%. So 100% plus 8%, that gets me 108%. 108% as a decimal is, if I move it 1, 2, is 1.08. So now I'm just going to go off to my equation. The original price, which was $50, times my percent that I found, so 1.08. Put that in a calculator. That gives you $54. Now, there's another way we can do this without our equation. That would be my original price of $50. Multiply that by my sales tax of 8%, which 8% as a decimal is 0.08. So multiply that by 0.08. That'll get me $4. So $4. Since it's a sales tax, I need to add that $4 to my original amount. So I'm going to take $50 plus $4, and that is going to get me $54. Either way, we got the same price. So you can either break it apart and do it this way, or you can do it all together like that. Either way, you're going to get the same answer. Now, a deduction is very similar. The only difference, instead of adding like we did here, we would be subtracting. So shoes normally cost $80, and they are 20% off. So again, 100% of $80 is $80. So I'm going to write 100%, but I don't have to pay 20% because it's 20% off. So I'm going to do 100% minus 20% because I get 20% off. That means I have to pay 80% of the value. So now I'm going to take the original cost, multiply it by the decimal I found. So move that over. That is 0.80. So 80 times 0.80 equals $64. Again, we can do this one without an equation as well. We would just do it 80 times 0.2. That's going to get me $16. And then since it's a deduction, or I'm getting a percentage off, I would do my original price minus the number I just found. So 80 minus 16. It's going to get me, again, the same price of $64. Two different ways to do it, but you're going to get the right answer either way. Now we need to move on to percent change. So percent change, we can have either a percent increase, meaning we're getting bigger, or we can have a percent decrease, meaning we're getting smaller. So let's do this example. Our equation for this is always going to be new minus old. So the new value minus the old value over the old value. So when we're looking at this, I think we're talking about a plant in this situation. It was Starting height was 7.1 centimeters. The ending height was 4.5 centimeters. So the starting height would be my old value. It's the not as recent one. So this would be my old. Ending height would be my new because it's the most current. So now I just need to do my math with it. So new minus old over old. 4.5 minus my old value of 7.1 divided by my old value of 7.1. Before you put this in a calculator, you have to make sure you have parentheses around this, or else you are not going to get the same answer as me. Now, if I do 4.5 minus 7.1 over 7.1, I get negative 0.366. This negative indicates that it is a deduction. We are taking away, okay? Now, we have 0.366. I need to turn a percent to a decimal, or other way around. Turn a decimal to a percent. So to do that, I move it 2 spots to the right. So now I have negative 36.6, or we can say we have a 36.6% deduction. So we have a 36.6% deduction. That negative again just means that we are taking away, we are deducting. So from our old height to our new height, we are decreasing it by about 36.6%. Now, with a percent increase, we're doing the exact same thing. New minus old over old. So I'm going to go new, which is my newest price. So 90 minus 60, put that in parentheses, over 60. When I do that, it is going to get me 0.5. There is no negative here. So that means we are increasing. So 0.5 as a percent, we move it over 2, we get 50%. So we have a 50% increase. So one way to figure out that we have a increase or decrease is just to see if we have a negative in front of our math. If we have a negative, it's a decrease. If we don't, it's an increase. Another thing we can look at is our old and our new. When our old value is larger than our new value, like in the first one, it's a deduction. When our old value is smaller than our new value, like in the second one, it's going to be an increase. So that's 2 ways that you can kind of look and just see if it's going to be an increase or decrease real quick. Next, we have percent equation. If you couldn't tell, there's a lot of equations that we're going to be working with on this one. So the percent equation is the whole value, multiply it by the percent as a decimal, and that'll get you your part. So if a car depreciates at 12% every year, how much would a new car depreciate in a year if it costs, and then it gives us 3 values. So we're going to do this 3 different times. So it depreciates at 12% every year. 12% as a decimal is 0.12. Okay, so we're going to use 0.12 this whole time. So now my equation, whole times the decimal. 35,000, we need to ask ourselves, is that the whole price of the car, or is that the part I'm getting off? 35,000, that's the whole price of the car. So I'm going to take my whole price of $35,000, multiply that by my percent as a decimal, so 0.12. When I do that, I'm going to get $4,200. So that means in 1 year, my car has lost $4,200 in value. Drove it off the lot, waited a year, it lost $4,200 in value. For this next one, my whole price, again, I would do 45,000 times my decimal equals, and then this one, it gets me $5,400, meaning in 1 year, my $45,000 car lost $5,400 in value, so it's no longer worth $45,000. Finally, we have a car that's $20,000, multiply it by our percent as a decimal, and then that is going to give us $2,400. So that means in 1 year, again, this car lost $2,400 in its value. It's no longer worth 20. It's more now worth like 17.6 or something like that. Okay, so now we're going to continue with this 12% onto the next page. So on this next page, it says, if a car lost $3,600 in depreciation after 1 year, what was the original cost? So again, we're going to use the equation whole times the percent equals our part. We just need to ask ourselves now, do I know the whole cost of the car? No, I do not. It's asking what is the whole cost of the car. So I don't have it. So I'm just going to use a variable of W. Now, I do know my percent. It was 12. We are still using 0.12 equals the part, which is the amount of depreciation after 1 year, which was $3,600. Now we have our equation set up. I can just solve this. So I need to ask myself, what's happening between my variable and my constant? Well, there's no sign here. So the imaginary operation is multiplication. Since there's no sign, I know it's multiplication. So undoing multiplication, I divide. So I need to divide by 0.12 on both sides. When I do 36,000 divided by 0.12, I get my whole value of the car equals $30,000. So the original cost of this car was $30,000. All right, lastly for us, we are going to be doing percent increases and percent decreases with geometry. So with, in this case, cubes. So consider the cube shown. The side lengths of cube B are 20% greater than the side lengths of cube A. Determine the volume and surface area of each cube. So before we get started, I don't know the side lengths for cube B. I know all of them for cube A because a cube is made of squares and it has same sides all the way around. So I know one side is 2.5, so that means every single side has a side length of 2.5. Now, I do know to get, because now we got to find cube B's side lengths. I do know that cube B side lengths are 20% greater than cube A's. So I'm going to go back to what we did at the very beginning. This is 100%, okay? So 100% of this would be 2.5. Now I need to add 20% to that. That's going to get me 120%, which is equal to 1.2. Now to figure out the side lengths for that, I take the original side lengths, which is 2.5 inches, multiply that by 1.2, and that is going to mean each side length has a measurement of 3. Okay, so now we figured that out. That's the hardest part. Now we just have to plug some stuff in. So first we're going to do the surface area for cube A. So surface area is the area of one of the faces, which in this case our faces are all squares. So the area of one of the squares, and then multiply that by how many faces are on this shape. So the area of a square is length times width. So I'm going to go the length, which is this line, times the width. So 2.5 times 2.5. And then once I take the area, I need to multiply that by how many faces there are. A cube has 6 faces. So I'm going 2.5 times 2.5 times 6. When I do that, I get 37.5 inches squared. For cube B, again, I'm going to do the same thing. It has side lengths of 3. So 3 times 3 times 6. I don't need that parenthesis there. But 3 times 3 times 6. That is going to come out to 54 inches squared. So again, to figure out my side lengths on this, for B, to get 3, I knew that they were 20% greater than the side lengths of A. So I did it to where I did 100% plus 20%, and then I did that as a decimal. I also could have done 2.5 times what is it? 2.5 times 0.2. That's going to come out to 0.5. And then I would have just done 2.5 plus 0.5 to get my 3. Okay, so that's how I got that. But that is our surface area for each of those. Now, that was just one part of this question. The second part wants the volume. So the volume of a cube is the length times the width times the height. Again, we're fortunate that these are squares, so every side length on this is the exact same. So for our first shape, we would have done 2.5 times 2.5 times 2.5. We can put that in our calculator, and we get 15.625 inches cubed. Since we're doing volume, our answer is cubed. So 15.625 inches cubed. To do our next one, we go 3 times 3 times 3. Again, put that in the calculator. You're going to get 27 inches cubed. All right, I hope that this helped you out a little bit.